So in this video, I'm going to set you a couple of questions on calculating the equation of a polynomial from its graph. What I want you to do, look at the questions, take on board the information, pause the video, have a crack at them, and then come back and check your solution with the solution I'll present here. So, here you go. Calculate the equation of the following two polynomials. So there's your first polynomial on the left. All the key bits of information are given there for you. Second polynomial, it's there on the right. There's your key bits of information. Pause the video and have a crack. So the first graph given by this. Now remember, when we're looking at getting the equation of the polynomial from the graph, we need two things. The first thing we need is the roots. The second thing we need is the y-intercept, or a key point. Now in this case it's the y-intercept. It could also be a key point on the graph somewhere. So let's use this information. We've got the roots here. We know the roots occur at x equals -5, x equals 1, and x equals 2. We also know the general format of the equation is y equals k bracket x minus a, x minus b, and x minus c. And I know it's going to be 3 brackets because there's 3 roots. None of the roots touch the x-axis and go, so there's no repeated roots anywhere. It's 3 separate roots. Now a, b, and c come from these, so I could set -5 to be a, 1 to be b, and 2 to be c. What I can then say is y equals k bracket x minus a, so -5 is plus, so x plus 5, x minus b, so x minus 1, x minus c becomes x minus 2. So I've got the first stage here. My second stage is to use the point or the y-intercept to get k. Now I know my y-intercept in this one is given by 0, 20. So what I can do is substitute the values in here for that. X is 0, y is 20, and I get something for k. So let's substitute and subtract. So 20 equals k bracket 0 plus 5, 0 minus 1, 0 minus 2. So 20 equals, well, 0 plus 5 is 5, there's -1 minus 2, so it's 5 times -1 times -2, that gives me 10k. From that I can simply say that k equals 2. Substitute it all back in, and I get y equals 2 bracket x plus 5, x minus 1, x minus 2. There you go, I've got my equation of my polynomial there. You could expand it as well, multiply out the brackets. Do that, you get y equals 2x cubed plus 4x squared minus 26x plus 20. That would be your final term. So there you go, you've got the graph multiplied out. Same set of steps. First we use the roots, second we use the y-intercept, or the key point we've got. Second equation was given here. Now, this one again, we want the same 2 steps. We want the roots and we want the y-intercept. This one has a difference though. This root here touches the x-axis and goes back on itself. So remember what we said about that in the video. This one here is a repeated root. So this one here is a double. So this is going to be a squared. So what I know from my roots is that x is equal to -3 and x is equal to 1, but that's a repeated root. I know I've got a repeated root, so my general form is going to be y equals k bracket x minus a, x minus b, but one of the brackets, let's say the x minus b, is going to be squared, and that's where the repeated root goes. So I know then that y equals k bracket x minus a, -3 becomes plus, so x plus 3, and then x minus b, 1's my repeated root, so x minus 1 squared. So I've got it there, but I've still got my k. And again, this is where the y-intercept comes into play. So I know I've got the point 0, 9. We substitute in. We've got y is 9, x is 0. Put it in here and solve it for k. So at 9 equals k bracket 0 plus 3, 0 minus 1 squared. So 0 plus 3 is 3, 0 minus 1 is -1, but it's squared, so that's 3k. So I know 9 is equal to 3k. From that, I get k is equal to 3. So I can stick it all back in here, and what I get is y equals 3 bracket x plus 3, x minus 1 squared. Again, could leave it in this form, that's fine, but if asked for an expanded version of it, multiply all the brackets, and what you get is y equals 3x cubed plus 3x squared, take away 15x plus 9. There you go, you've got your final answer. Key to remember that you need those two bits of information. You need the roots, and you need to determine if any of them are repeated roots, and you also need the y-intercept or a key point. If the graph goes through the origin, you'll need another key point somewhere on the graph. You can't just use 0, 0. You won't get the answer you're after.